Analysis of a bifactorial experiment in a split plot design. To illustrate this example, we will use the test data named wheat_water_genotypes. It presents the results of a factorial experiment designed to study the effect of irrigated and rain-fed conditions on the yield of several wheat genotypes. The design is a split plot design. Each replicate is a block with two main plots randomly assigned to irrigated and rain-fed conditions. Each of these plots was subdivided into smaller plots to which all wheat genotypes were randomly assigned. Thus, this is a bifactorial experiment, conducted in complete blocks. Blocks contain all combinations of genotypes and irrigation conditions, but it is not a complete randomized block design because the allocation of treatments is not random but constrained. First, the irrigation levels were assigned to main plots, and then, in a second step, the genotypes were randomly assigned to each of the subplots of the main plots. Because of the way the model is fitted, we need to identify the main plots. This is easily done by merging the rep and water columns. We will rename the resulting column main plot, just for clarity. To analyze these data, we will call the LMM, linear mixed model, procedure. We choose the yield as the response variable and genotypes, water, rep, and main plot as classification factors. Then we press the play button in the upper left corner of the window. Then, in the window that appears, we add the terms, genotype, water, and their interaction to the fixed terms list, and then, selecting the Random Effects tab, we drag the rep and the main plot, in that order, to the random terms list. We will also request the multiple comparison table of means for water and genotypes combination. You must wait for the procedure to complete and display the results. Finally, we can get the table of means for the previously requested table of means. This is done by pressing the Tables to Navure button and selecting the corresponding table of the report. As a graphical summary of the results, we request a DOP plot chart of the means. To obtain this chart, we press the button DOP plot chart, and then we select the mean as the variable to be plotted on the y-axis, the genotypes to be plotted on the x-axis, and water as the partitioning criterion to obtain different points for irrigated and rain-fed conditions. We also want to associate the letters that identify the different groups according to the multiple comparison test and the standard error of the means. To improve the visualization, we change the color of the rain-fed series by selecting the series tab, and then changing the color. We also change the label of the y-axis to indicate that it represents yield. In this chart, we can see that genotype K, which is a high-yielding genotype under irrigation, is also a high-yielding genotype under rain-fed. In contrast, genotype G, which is in the higher yield group under irrigation, is in the lower yield group under rain-fed.